How's it going, everyone? Dax here, and today we're reacting to the new Cosmos Art video, reacting to Ancient Life as Old as the Universe. Video being transparent mode, like always with Cosmos Art videos, just in case of copyright block problems. But anyway, let's get straight into it, and away we go.
The 12,024 calendar is here. Get it now before it sells out. And stay tuned until the end of this video for a sneak peek that's out of this world. Life has existed on one planet for about 4 billion years, as far as we know. But it might have started right after the Big Bang, when the universe was much stranger and more fantastic than today. A universe that might have allowed life to develop absolutely anywhere. The cosmos might be full of the seeds of life, sleeping in a dead desert, waiting for a few drops of rain to explosively bloom and grow. Tiny and not so tiny aliens might be everywhere. In this video, we're going to put together two highly speculative yet scientifically grounded possibilities. Check out the scientific papers in our sources. To properly explain it, let's first look at the paradox of life on Earth. The life paradox.
It's crazy to think that we're the only planet with life, any form of life. Like, you're not looking at any like microscopic life. We can't actually tell because we can't go anywhere yet, but you know what I mean? Like, we can't see any sort of life.
For its first few 100 million years, Earth was a magma hell, constantly bombarded by asteroids. But basically, the second things calmed down and the first oceans formed, life just appeared, and zillions of microbes settled every nook and cranny they found. This is kind of strange. Life on Earth seems to be almost as old as the planet itself, as if it was waiting around for an opportunity. But life didn't only appear extremely quickly. In that tiny time window, it also crossed a huge gap. To qualify as living things, even microbes need to eat, poop, grow, and multiply. To do that, they need a genome, the biological instruction manual that sets the inner workings of an organism. How dead things with no genome become living things with genomes is one of the biggest riddles of science. Simplifying a lot, the problem is that to have a functioning genome, you need proteins, and to make those proteins, you need a functioning genome. Both proteins and genomes are super long molecules made of pretty complex blocks that are extremely difficult to assemble by chance. It's a chicken-egg paradox with several chickens
what came
and
first?
eggs. Once you have a finished cell, the whole system works efficiently. But starting from simple dead stuff and reaching that level of sophistication by pure chance should require an amazing amount of time for trial and error. So how did the first living things manage to cross that gap in just a few 100 million years? Most theories about the origin of life try to explain that gap by theorizing how some primitive soup of prebiotic molecules could have efficiently produced the first self-replicating entities. But we still don't know how exactly this would have worked. Maybe we need to think backwards.
How are we doing that?
The clock of evolution. Think of genomes as a book telling the history of life. As time passed and life evolved, more characters were introduced. Amoeba, fish, amphibians, dinosaurs, and mammals. Over billions of years, the story of life got more and more complex. A genome can be viewed as a long string of letters with biological instructions. And from
evolution
microbes to us today, functional genomes seem to have been increasing in size at a fairly constant rate. The functional genome of fish is more than twice that of worms. Our functional genome is about twice bigger than that of fish, and so on. It is a bit more complicated, but for now, let's run with this.
He's keeping it simple, I like it.
When we put all these clues together, it seems that genomes have been doubling in size on average every 350 million years or so, as if evolution had been following an exponential inner clock. But it gets even stranger. The very first microbes that emerged on Earth, even if they look simple, already seem to have had pretty long and complex genomes. But how could life have achieved that level of complexity in such a short time?
You're trying to say there was already life beforehand, and then...
There may be an interesting way to solve this riddle. We just take our exponential clock and extrapolate it back in time to the simplest conceivable life form. Something equivalent to a being with a genome containing just a few letters. But if we do that, we end up 10 billion years in the past. More than twice the age of Earth, which means If life actually evolved like this, it didn't start here, but somewhere out there, in space. This would explain why life started to thrive so quickly on our young planet. If it was already present in space like a seed, it just needed water and warm temperatures to wake up and go on evolving. And it would also explain the high degree of sophistication of the first life forms on Earth. They could have been complex.
This would also back up my theory that humans are a cancer of the Earth.
already, because they might have been evolving for billions of years somewhere else in the universe. But could life really be that old? Maybe, yes.
Of course.
Actually,
yeah.
Life could have started shortly after the universe itself was born. A Goldilocks baby universe. At its most basic level, life needs two things: the right chemical elements to form complex molecules, and a liquid medium, like water, in which those molecules can move and interact. The liquid medium needs to stay warm enough to remain, well, liquid. So when we search for life in space, we focus on Earth-like planets at just the right distance from their star, warm enough to sustain liquid water. But there was actually a time when almost all of the universe might have been habitable. Right after the Big Bang, the universe was extremely hot. But as the cosmos expanded, it cooled. And between about 10 and 17 million years after the Big Bang, when the universe was 1,000 times younger than today, it was between 100 degrees Celsius and 0 degrees Celsius, the temperature at which water is liquid.
Like, we're talking about life now. We're not even talking about intelligent life. We're just talking about genuine life out there. So I'm not being funny. It might not even need a water planet. I don't. Maybe the water was a big factor in it, obviously. But I'm just saying, like, it could be a different type of creature, animal, species of something out there that we just don't know about because we can't actually see it.
So for this window of time, more than 13.7 billion years ago, the whole universe, absolutely every inch of it, had the right temperature to support life. Of course, the right temperature alone is not enough for life. We also need chemical elements like carbon and oxygen, which are forged in the cores of stars. But were there stars?
That's the thing as well with science. Like, that is like detrimental to our life, but doesn't mean it will be detrimental to like alien life, for example. Like it just because we've made these theories on these elements and these things that combine to make this and all that lot, it might be completely fake, not completely wrong, and there could be a completely different theory out there that no one knows about yet because we don't know about everything. Do you know what I mean? So it's scary thinking about that.
Times? Maybe, yes. In regions of the universe where matter was especially dense. Such stars would have been very massive and gone supernova in just 3 million years, seeding the baby universe with the chemical elements needed to form dust, asteroids, planets, and the ingredients of life. Maybe the first ancestors of life were more exotic and didn't even need water, but thrived in substances like ammonia or ethane that can stay liquid at temperatures far below 0 degrees Celsius.
Oh, so it has to be liquid,
they could have been sustained by the lingering warmth of the Big Bang for tens of millions of years longer, well into a time when we know for sure there were stars and all the chemical elements.
Oh, wow, okay.
The real magic of this idea is that while the universe today is extremely deadly and hostile, back then, the conditions for life might have been basically everywhere. For a period that may have lasted several dozen million years, primordial life might have been able to emerge on any rock, even between the stars, sowing the universe with the seeds of what, billions of years later, would become bacteria, trilobites, dinosaurs, and finally us.
We were just one big accident, man. That's just so sad.
At some point, the universe cooled down below the right temperature for life to thrive, but some of those ancestral life forms may have continued to exist in the internal warmth of the first planets, frozen in asteroids or hibernating in cosmic dust. Tiny seeds roaming the cosmos, waiting for new hospitable places to continue evolving. If they
Another question, if it laid dormant in like planets and say so, and then we got to the point where we got so evolved we could bring that water to that planet or bring what that planet needed to sustain life, could that be a possibility? I know it's all like theoretical and stuff, but I just want to know that. That's kind of cool.
Life now might be everywhere in the universe. Will we ever know?
I hope so. I don't think we will.
Story. And
But I think
while
maybe the
both the
future
habitability of
generations,
the baby
maybe.
universe and our exponential clock of life are reasonable ideas, they're still speculative.
Everything's
One
theory
more
when it's
possibility
science.
among many others trying to explain our existence today. But if life came to Earth from outer space, then it should have seeded other places in the solar system too. Maybe there are fossils in dry riverbeds on Mars. Maybe we'll soon find life in the warm underground oceans of Enceladus or Europa. Titan has seas, rivers and lakes of ethane and methane as warm as the universe when it was 90 million years old. So finding exotic life on Titan would support the idea that life could have originated in the weird baby universe. So far, when we look out into the cosmos, we don't see anyone like us. But maybe that's because life needed 10 billion years or more to reach the level of complexity that allows for a technological species.
Yeah.
Maybe there are millions of worlds filled with microbes,
That's what I'm
oceans full of
saying.
exotic fish,
Yeah.
and continents of bizarre animals. And maybe even others like us that just recently gained consciousness and are beginning to look at the sky.
That's a tough one, isn't it? Because I think finding intelligent life might be next to maybe impossible. I think we're at the end of the scale. Like, I think everyone else is, everyone was already intelligent, and then this is just like with the aftermath of it. But I don't know. It's also like the theory of, you look at the ant. Like, from our perspective, they're just existing. We just ignore them. They're existing. They're doing their own thing. They're not as intelligent, but they're an intelligent creature, but not compared to us. You know what I mean? So we're doing our thing. So if there's someone out there that is intelligent, but then we look like ants to them, they're obviously not going to want to talk to us or acknowledge us in any sort of respect. So it makes sense, right?
Wondering if they're alone.
If there was intelligent life, it'd
could
be more intelligent than
flourishing
us,
right now
maybe.
in uncountable forms and in all kinds of cosmic environments. And if many of us share a common cosmic origin, we would all be part of a great cosmic family. The answer may lie in our cosmic backyard. Let's go and find out. It's time. Let's reveal the 12,024 human era calendar with a big bang. The Kurzgesagt calendar is special because we're adding 10,000 years to include all of humanity, no matter their culture or origin. 12,000 years ago, humans first started working together on a larger scale, laying the foundation for civilization and the future of us all. A much better representation of how far our species has come. This year, we're looking at the cosmos and all the possible life that could be thriving on myriads of worlds, hosting radically different animals and beings from the ones on Earth. Where in the universe might life exist? And how would different cosmic environments affect the bales out? Thousands of burbs who get the...
Okay, that's the... Make sure you check out the Kurzgesagt store. They've got a lot of cool stuff, especially this cool looking calendar and yeah, pretty cool. Anyway, yeah, that was a pretty good video. Yeah, space is kind of gnarly, man. Like, it's a bit unpredictable. We don't really know a lot about it because we've not really been there. We sent probes up and stuff, but when it comes to people going up there, they literally just go up there and come back down. So it's not like, not many planets have been landed on. We're still not got as far since the 60s or 70s. I can't remember when the moon landing was, but you know what I mean? We've not done anything drastic. I know there's people out there trying. They got NASA and Elon battling it out, but it's like, yeah, it's kind of just weird, man. Like, at this rate, we're not going to find intelligent life until it finds us, because we're not going anywhere with it. People are trying, but I don't know if we will. Anyway, good video. I will see you in the next one. Make sure you check out the original inscription down below. Laters.